Professor, our contract homework 3.
Sorry, what did you say? Sorry.
Contract homework 3.
Well, Jordan's the one grading. I don't know if he's the one grading yours, but you're gonna upset PA, that's for sure.
The files
like besides the run
like I just copied this message to the
oh, I wrote mine.
oh, you just didn't
That's good.
Well, I tested it in 3 minutes.
yeah.
Wrote it in here.
Yeah, we're gonna transition into that after. What's that, Razor 17 or
Yeah.
15?
15. It's terrible.
What's the graphics on it?
It's like warped.
Oh,
Because it gets so hot.
I think that's the battery, right?
Yeah,
You have to replace it.
it's trash. Oh, it's trash laptop.
I have one, I thought it was okay.
I mean, in theory, it's good, but like in practice, get a tap. 2020.
Mine was 2020. Let's wait for 30 more minutes. So the plan for today, we will go over the homework assignment together. I'll write it for you, and then we'll do and then you guys will tell me what your favorite number is. And after that, we'll talk about some new stuff if we have time. Also the midterm. So next Monday there's no class, right? Right, President's Day. So I'll make homework for due on Wednesday before the class. And the midterm, I'm thinking, well, we have to get it done after Wednesday's class and before the class before a class in the next month on the next Monday. So either Thursday or Friday or Saturday or Sunday. I'll give you guys 24 hours to complete it. But I'll probably run a poll on Piazza asking you guys which day you guys want the midterm to be on. It doesn't make a difference to me, honestly, because I'll just put it up 24 hours and only take submissions within 24 hours. Okay. Does that sound fair? Yeah. Okay. So that's what we're gonna do. I'll put out a hey Jordan, can you post a poll on Piazza asking so Thursday, Friday, Saturday, Sunday next week? What else can I talk about? That's it. I think that's it. Okay, so let's start going over homework 3. Okay, so everyone. So what I'm going to do is first I'm going to write my solution, show you guys how I approach these questions. Okay, and then you'll tell me your favorite number, and then I'll randomly. I won't tell you who, but I'll randomly pick someone's homework 3, and then. I'm not going to say who, so if you don't make a noise, nobody's going to know it's you. Okay, I'm not going to show the names. I'll copy and paste it into Remix. I'll remove all the personal information. Okay, so no one should know who it is, and I'll just look through it and then talk through it because I think it helps more if I grade it this way. Okay?
Actually, met in person.
And if anyone wants to volunteer, that's fine too. If you want to share, that's totally fine. That's fine by me. Otherwise, it's going to be random. So if someone wants to take one for the team, you're welcome to. Okay, so let's look at homework 3. Okay. Okay, here we go. So first, the contract structure. The open source license, okay, it should be unlicensed. So this should say, so this line should be here, first of all, otherwise Remix will give you a warning. And secondly, this should be unlicensed, okay? And secondly, enforce compiler version 0.8.0 or above. That means this line, okay? Pragma solidity with this little sign here, that means above. That means whatever version and above, okay, 0.8.0. Without this, it's just 0.8.0. Okay. And then contract should be named homework 3. So contract homework 3. Okay, and also on the submission guidelines, says submit a single solidity source file, homework 3.sol. This is very important. And also it's case sensitive, right? The reason being, so this time we can kind of be lenient on this. But Jordan and the other TA will hit you because they have to manually look at it. So what happens is the reason why I need you guys to match this so closely is because let me show you. It's because I wrote a custom grading script that will look for the specific file and then look for the name of that specific contract. Okay, so all the TAs have to do is they will replace they will download the grading repository, download the grading code, and then they'll just replace the contract file for yours, and then they'll directly run this. Okay. The reason why it's important is because, like the naming matters here, including the case. Okay, because I'm importing. So if your name doesn't match, then it's not going to find the import, and the testing script's not going to run, and Jordan will hate you because he has to now manually do it instead of just doing it automatically. Okay. So that's the reason why I keep emphasizing, and including I made a Piazza post saying how to get a 0 on homework 3. You won't get a 0 this time, but you will next time. Okay, because I've said it. So the file name and contract name, everything case sensitive, it has to match. Okay. And next time I'm probably going to help you guys by including a part of the grading script inside the GitHub repository directly. So every time you submit, it will run some tests and show you what works and what doesn't. Okay, so you have a general idea of if your code works. And then I'll run some more test cases. Okay. But anyhow, so that was regarding the naming conventions. Okay. So we have the contract structure down. All right. Now let's move on to standalone functions. So the first one, we write a function that's named, and also I clarified on Piazza later. Standalone functions, I was referring to pure functions. Okay, they shouldn't be view; they have to be pure. Okay, meaning these functions should be self-contained. If I copy this function and paste it into another random contract, it should still work. Okay, because it's pure, it's self-contained. Right? And I don't really see why. I mean, I don't, but you're not supposed to modify anything. Like you just don't have to do it. Okay, so let's do the first one. The first one is a function called do math. All right, I'll just write a function do math, and it takes in two 256 parameters. Okay, so type name, and again, the names can be the variable names. You can make them up. You can say number 1, number 2, whatever. All right. So that'll be external and pure. Okay, and because we have to return some number, so it's got to return. It's also got to return an int 256. It can't be uint because the input also includes like negative numbers. Because okay, and what are we supposed to do here? Yeah, it's frozen again. I'm just waiting for the Wi-Fi. It's not working. It's actually really unhelpful. The Wi-Fi works. Why is it not? I'm really. Oh, there we go. Right after I Googled Zoom stuck on starting to share screen. Okay, we talked about, so what happens in the function, right? We take the two numbers and then we multiply them by 2 and then return the sum. So we multiply A by 2, multiply B by 2, and then add them together. So we can do that on one line, okay? So just return A times 2 plus B times 2. Okay, that's the answer to the first one. Okay, and stop me anytime if you have any questions, okay? Now, the second one, we deferred it to homework 4, so we'll skip this one. Get max, we'll skip it. The third one, write a function that is named hash string. And by the way, if you've already done get max, for homework 4, you just have to copy and paste what you already have into it. So it's one less problem for you to do. Number 3, write a function that is named hash string array. Okay, so let's write it first. Hash string array. Okay. It takes in an array of string. All right, so we do string, and that's an array of string. When we can call it array, whatever. What you call it doesn't matter. This doesn't matter. Okay. And it returns an array of bytes 32, which represent the hashes of the input string.
Why you call that answer?
It doesn't matter. Pure returns and return bytes 32 array. It's call data because it's just a general rule to use call data whenever you can. But when you return, you cannot, because call data originates from the external call.
Right.
And for the memory thing, we're creating it within the function, so it can't be called.
I use storage. Is there a difference
Storage where?
for call data?
I don't think it compiles into storage, does it?
I think so, but it wouldn't let me do pure. I had to do view. So maybe there's something to do with that.
I don't think you can like this, because it's going to tell you you can't. And if you did view, I suspect, wait, oh, sorry, what's your name again?
Jaden.
No, I don't think that's what's yeah, I look at people's code on GitHub. Yeah, so we'll talk about that one later, okay? So the function named hash string array that takes in an array of strings, and it's pure again, standalone, returns an array of bytes 32 hashes. Okay. And what we have to do here is we have to first create a memory array of type bytes 32. All right. And when we create a memory array, it is a dynamic type, but we can't push to it. So it's basically a fixed size array. And for a fixed size array, what we have to, so when we're creating a memory array with the new keyword, we have to give it a size, right? And where does the size come from? Well, we have to think about it, right? What does the return value represent? It represents an array of hashes that corresponds. So each element in the bytes 32 array represents the hash of the corresponding element in the input string array, right? So what we're doing essentially is we're iterating over the input string array, element by element, and for each element we hash it and store it into the byte 32 array. Does this logic make sense to everyone? Yeah. Okay, so what we'll have to do is step one. We'll have to create a byte 32 memory array. Okay, we'll just call it return value. All right, so it's gonna be a new byte 32, and then we have to give it a size. Okay. Because each element in the byte 32 array corresponds to the elements in the string array, so it's logical to think that their sizes are the same, right? Because if it's a one-to-one relationship, then however big the input string array will be, that's how big the output byte 32 array has to be, right? Like if I said, here's a list of 5 numbers, add 1 to each number and then give me and then return me the list. How big will be the return list? So I'm giving you a list of 5 numbers. I'm telling you to add 1 to each number, and then give the list back to me. How big will be the list that you give back? Still 5, right? Because you're going through each input element in the input array. You're going through each element in the input array. You're adding 1 to it, and then you're saving it or overwriting whatever, saving it into another list, and then you're giving me back like the new list. And this is more or less what's happening here. I'm giving you a list of strings, so just a list of words, whatever, okay? I'm asking you for each element in the input string array, perform a certain operation on it, and then save the result into a new array, and then give me the new array. How big would the new array, how big would the new array be? That'll be, it should be the same size as the input, right? So here we can, when we're creating this new memory array, we can just set the size to the input array dot length. Okay, so this will make it so that the memory array, okay, I'll use lithograph. So this is basically saying that the memory array that we create is of the same size as the input string array. And what this does right now is it's creating a new byte 32 memory array of size input array, and it's filling everything in there with zeros. Okay. And the next thing that we have to do is we have to find a way to iterate over every single element in the input array so that we can perform some operations on each individual element. Right? Now, because you don't know, well, you do know the length, but because you don't know how long of an input array the user will give you when you're writing the code, so you have to make it dynamic, right? So we have to make use of a loop, because what a loop does is a for loop can start from some number, and it can go up to a certain number, all right? While iterating, through it one by one, incrementing. Okay, so what we do is for let's declare a UN, just call it I for index. I equals 0 because we want to start from the very first element. And again, the index starts from 0. Okay, so this is the our starting point. Okay, and following it is the condition that ends the loop. Okay, sorry, the condition that sustains the loop rather. Okay, so for I equals 0, and while I is smaller than the length of the input array, while I is smaller than that, we increment I. Okay, so what this will do is I will start from 0. It will check, is 0 smaller than the size of the input array, the length of the input array? If it is, sorry, it will first start from 0, go through the for loop, and then I'll go back and check, is 0 smaller than the length of the input array? And if it is, then we increment it by 1. And then we go through a loop again, and we check the condition, is 1 smaller than the length of the input array? And if it is, then we increment it by 1. So now we're at 2, and then we go through the loop again. Now, once we hit the length of the input array, let's say the input array is of length 5. And after the loop of I equals 4 goes through, it'll go back. It'll go back. Okay, sorry, I think I have to look backwards. But it will eventually hit the length of the array. All right, and once it hits it, it will then exit the loop. Okay, I think I have a little backwards. But what I'll do here is, so the essence is, if the input array is 5, I will go through 0 to 4. And then when I hits 5, the loop will exit. Okay, so what we can do here is for each input, for each element in the input array, we will hash it based on what you're given. Okay, and then save it to the by32 array. Now, I saw some people's code on GitHub and some questions about using push. And remember, a memory array is always, well, it's a dynamic type, but because it's a memory array, so the size is fixed, you cannot push to a fixed size array. Okay, you can only modify what's already there. And the size is defined when you first declare the array. Okay, so what we're doing is, we're basically saying, for the first element in the input array, we'll hash it, and then we'll store it as the first element in the return array. And then for the second element in the input array, we'll hash it and store it as the second element in the output array. Okay, so what we're doing here is basically we're assigning the value at a certain index in the return array as the hash of the element at the same index of the input array. Okay, so let me just copy this. And we have to replace this with the actual string that we're trying to hash. Okay, so that would be array at I. And then finally, we'll just return the memory array. Does this not make sense to anyone? We can go through this again. I feel like this is some people tripped on this one. If you have any questions, please don't hesitate to speak up.
I had a question.
Yeah.
So like, this was just like something that was an easy fix, but why do you use a uint 256 instead of a int 56 to iterate through the loop?
It doesn't matter really, but one thing is you're never going to have a negative index, unlike Python, which does. So it's never going to be negative anyways. But again, it's not like you're using the entire range of uint 256, so it doesn't really matter if you use int or uint.
Okay, yeah. When I tried with int 256 and it threw me an error, so I just.
Okay, so it's probably the compiler because again, the arrays are not supposed to have negative indices. So I'm thinking if you use an int, the compiler thinks you're doing something that's not safe.
Got it.
So it stops you from doing it.
Okay, that makes sense. Thank you.
Could you just go over why you used call data when you labeled array as opposed to storage or memory?
You cannot use storage because storage refers to a certain storage location within the contract. But the caller is a human user. And it's not a part of the contract, so you can't use storage.
So then why can't you use memory?
You could, but it's just a rule that whenever you can use call data, you do.
Okay.
Yeah. Because memory, so what memory does is it reads what the call data is, and it copies the values over for no reason.
When you say that it copies it, do you mean on like a meta level, or like you can actually access the original data as well and the copy?
You can't access, well, you can access the original one. I'm thinking by doing message of data, I'm not too sure, but do you have any other programming experience? Okay, I was going to make an analogy.
Yeah, and probably not enough to understand your analogy.
Yeah, no. If you understand like C language, then I can make an analogy that's much clearer. But so basically, call data just means let's say I wrote 1 + 1 = question mark on a piece of paper, and I want you to solve it. Call data is just looking at my piece of paper and just writing 2 on your piece of paper. Memory is copying down 1 + 1 equals and then writing 2.
Oh, okay,
It's a step that's not necessary.
that makes sense.
Any other questions? That was a good question. I think I'm gonna remember this 1 + 1 knowledge. I think that's.
Is there a case when we should use memory, not call data, like underneath that context of using call data?
I don't think so. I mean, if you cannot use call data, it's gonna tell you. Right? See, if I have call data here return, it's gonna say Vice32 memory cannot be converted to call data. Right? And the other reason why we can't use storage, remember the analogy about tables. So storage only makes sense within the storage context of the contract. Let's say this table is table number 1. If I tell you, while you're in this room, go to table number 1, you know which table to go to. If you're standing outside, I tell you to go to table number 1. And there are table number 1s in each classroom. Okay, if you're standing outside, I'll tell you to go to table number 1. You don't know what I'm saying because you're not within that context. So storage is a localized context that it's a pointer that points to a certain location within the contract storage, within the context of that specific contract. So it's like it makes sense when I tell you to go to the first table when you're in this classroom, right? But if you're in the hallway, I tell you to go to the first table. You don't know because you don't know which first table I'm referring to. Right? And storage is just we call it a storage pointer. So it just points to a certain place within the context of some storage. But memory is concrete values, right? So if you print out storage, which is difficult to do because Solidity doesn't allow you to print, you're just going to get back a hexadecimal number that represents a location within the storage, within the context of it. When you print a storage, when you print like a Vice32 array storage, you're not going to get an array. You're going to get an address that points to a certain location. But if you print a memory, then you're going to get a concrete value back. It's like you have a folder named new folder on your computer. You have multiple folders named new folder on your computer. And if I just told you to go to new folder, you don't know which one I'm talking about. But if we narrow it down to a certain directory which only contains one new folder, then I tell you go to new folder, you know which one I'm talking about. Too many folders. But for now, just remember when you're declaring a function. So on this line 10, you can only use call data or memory. And call data can only be used, in most cases, it can only be used as within the input parameters. The returns are usually always memory. There are very rare cases. I don't even know because I've never done it. I've never had a need to do it. So I'm not sure if you can actually directly return the call data that's passed into the input, but that's a very rare case that I don't think you have to deal with at all. Okay, so use call data where possible, if not use memory. But storage always refers to something a variable that you've already declared within the contract. It's not supposed to represent anything new. It represents something that's already there. Okay. Is that kind of helpful, I guess? But any other questions on this one? Pass string array function. No more questions. Okay. Let's move on to the fun part. Okay, fun, by fun, I mean miserable. Building a contact book. Okay. So we're basically building, I'm just going to read it. I'm not even going to read it because you already know what it is. basically a contact book. So for each address, and also when in the context of Ethereum Web3, whenever I say contact, I am referring to addresses. Okay, not any other kind of contact. So basically, so every single person can have their own list of contacts. That's what this program kind of enables. Okay, and we have some interface requirements. And interface requirements meaning that your function has to look a certain way. It must look a certain way. And again, this is because when I'm testing it, I am expecting a certain function signature. And if you change it, then it's not going to match up. And this is the same when it comes to software development in general. And this is why it's called an interface. So a lot of times you do not want to let other people know the inner workings of your program. And what you do is you give them a list of functions that you show them a list of functions that you want them to be able to call. But again, you don't want to expose the exact contents of the function. So you just give them the function signature so they know. So that's called a function, that's called an interface for them to call. So once you give it to them, you can't change your function, you can't change your interface anymore, because if you do, then it's not going to match. And when they call it, it's not going to exist. Okay, so this is why it's important for you to just copy and paste this verbatim. All right, so let's copy and paste this and turn them into concrete functions. Just delete the semicolon and then add the brackets. All right, so before we start coding, we have to, of course, we have to establish some data structures, right? And we have to think about this. So what's happening here? So you see we have get contact, get contacts given a caller that returns an array of addresses. Okay, now this is a hint. It means the data structure has something to do with address arrays. Okay, and if we think about it, what are we doing here? We're saying that for each user, they can have their own list of contacts. Now, list of contacts, that's that's an array of contacts. And what is a contact? It's an address, so it's an array of addresses. Okay. But so now let's move. So now we have it nailed for a single person, right? But then how can we make it so that each person has their own list? So each person is associated with their own array. And what is a person in Web3, in Ethereum? It's also an address, right? So an address, one address associated with one array. That sounds like a mapping to me, right? That sounds like a mapping that points from an address to an address array. Does this part make sense to everyone? How we kind of came up with this data structure of a mapping that points from an address to an address array. If you're confused, feel free to speak up. This is pretty important. Yes. Do you have a question?
Wait, why would it be a regular mapping and not a nested map?
It's not a nested mapping. It's not. Okay, so did you do a nested map?
Yeah, I tried doing a nested mapping.
So I'm guessing what you did is you did a mapping that maps from an address to an inner mapping that maps from an address to Boolean. Maybe.
Kinda, because I thought you would be connecting a name with a nickname. I thought.
Oh, that's the extra credit. So we'll get that later.
Okay, I did that for that too, because I thought you would be like attaching a name with a nickname. So I thought it'd be nested.
Yeah. So the problem with that is, how can you implement get contacts? How can you return a list of contacts? Because in a mapping, everything technically exists. So you can't check if someone exists without knowing if they exist, which is contradictory, which is circular. Like you need to know the information you're looking for to get the information that you're looking for.
I got that one wrong.
Next time it's fine, just you can post, if you have like specific code questions, you can post on Piazza, and we can talk about it, right? But that's for later. So for now, the answer should be a mapping that points from an address to an address array. Let's make it internal. Call it contacts. Does this part not make sense to anyone?
Does it matter here if it's internal or?
It doesn't matter. Any questions for line 18? No questions. Any questions? Okay, no questions. Right, so let's move on to get contacts. All right, so given the address of the caller, you want to return that person's list of contacts, right? Now, I also mentioned this on Piazza. Why can't we just why do we have to specify the address of the caller? Why can't we just say why can't we just use message.sender like we always do? All right. Why can't we use message.sender to figure out who's calling and then just return the list of contacts for that person? The reason this message.sender doesn't work here is because for view functions, they're read-only functions. So they're not modifying the state in any way, which means they're not submitting any transactions. And if there's no transaction, then there's no from and to. And then that's why there's no message.sender in a view function or a pure function for that matter. So message.sender is only useful in functions that actually create a transaction when you call it. A view function does not create a transaction when you call it. You're just looking at something, and you don't get charged for looking at something. All right.
I was just curious, could you repeat again how important is putting internal on that map?
For right now, it doesn't matter. I just wanted to put something there. It could be public, it could be private.
Okay.
So in some of them, if you'll just have external or for that internal, like if you don't put any keywords, is there like something it defaults to?
It defaults to internal if I don't put it for variables.
Okay.
And so variables cannot be external because it doesn't make sense for a variable to only be accessible from the outside. Then what's the point of having it, right? It's like I bought this car, but only other people can drive it. Right? It doesn't make sense. So for variables, it's only public, internal, or private. But for functions, you can have external. And if you don't put anything for a variable, it defaults to internal. But you have to put something for the functions. Otherwise, I'll say you have to state the visibility. But it's always good to be explicit. Right? Does that answer your question? Any other questions before we move on? Start writing line 22. No. All right. So we can actually return directly because this mapping maps from the address of the owner of the contact list, I guess, to the contact list. So if we're given the owner's address, we'll just return the value associated with it, right? So we can return contacts at caller. All right. Does this part make sense? So it's again a key value. What's a key value relationship here, and I'm giving it the key. So it returns the value to me, the associated value to me, and the associated value is an address array. Does this part make sense to everyone? Line 22. Okay. So let's move on. And you can still stop me and retroactively ask questions. That's totally fine. Okay, so here, adding an address to the caller's list of contacts. Okay, how can we do that? We can do that by, so first we, again, this one, notice, it's not a view function. It's not a view function because we were trying to add something to our storage context, so we're modifying. And when we're modifying the state, what does that mean? It means message.sender is available to us. We can use that to determine who's calling, because in this case, when we're modifying things, we're generating a transaction. And whenever there is a transaction, there is a from and there's a to. And the to is yourself usually, the contract. And then the from would be message.sender. Okay. So in this case, we already know the address of whoever's calling. All we have to do is add this input address to the existing list of contacts. Okay. So we can get the existing list of contacts by doing this. Does this part make sense? This is how we get to the message.set the caller's list of contacts. Yes. Okay. And remember what I said about mappings a while back. I said when you have a mapping, all the keys and all the values exist, right? And for some key that's never been set, what's the corresponding value? It's the default value, right? So for numbers, it's 0, string, empty string. But now we're pointing to an array. And what's the equivalent of 0 when it comes to arrays? That would just be an empty array, right? It's just nothing, right? So nothing in the context of a number is 0. Next, nothing in the context of a string is an empty string. This is nothing, and nothing in the context of an array is just an empty array, right? And you can think of it as, you can basically think of this as all the arrays. All the possible arrays have already been declared in this mapping. And where is this mapping located? Is it within a function or outside the function? Outside. And what happens when you declare an array outside of the function? Is it a storage or a memory? Storage, exactly. So all the arrays, when you're using arrays in mappings, all the arrays will be storage arrays. And you will be able to push to them, meaning appending things, meaning changing the size. Because they're storage arrays, you can modify it, you can modify the size. Okay. So this gives us the array. And what we have to do is we have to push to it. Okay. Now there are two ways of doing this. The first way to do it is we do address bracket, right? And then storage. This storage now, right? And we can name it contacts equals.
Jaggering is telling you it's gonna shut down.
What am I supposed to?
Press the buttons on that.
I did. It doesn't matter. It doesn't work. Alright. Doing this again. I'm gonna beat it if I turn it off. Folks on Zoom, I'm just restarting this piece of wonderful hardware. Because it's telling me it's going to shut down again, so oh, that might. There we go. That's how you show computers whose boss. Your computer is going to crash. Just unplug it before it crashes. Who's in control now? Computer, right? Okay, let's call in again.
Wait, can you go back up to show us what message.sender is referring to?
I also
Like,
figured
what-
out how to turn down the volume so it doesn't turn
Oh,
everyone
geez.
deaf.
Sorry about it.
There we go. Now we're back.
Cool. Can you,
Okay?
yeah, can you hear us?
Yes, let me turn up the volume again. Yes, I hear you fine.
Cool.
Alright.
Can you go back to show us how the function that created message.sender and how that is referred to in this function here?
Message.sender is never created.
Okay.
So this message variable is a variable supplied to you by Solidity. And when a transaction happens, so when someone calls your function, because your function doesn't just run by itself, someone has to call it. So when someone calls your function, it will fill in this variable with the relevant values. So, but what I was talking about was when you have a view function, because a view function doesn't generate a transaction, it's just reading something. So it's not modifying the state. Not modifying the state means there's no transaction, right? And when there's no transaction, there's no from and to, because from and to only makes sense in the context of having a transaction, right? Who started the transaction and who's the recipient, quote unquote, right? So that's why within the view function, message.sender is not available, because when you call a view function, you're not submitting a transaction. So if there's no transaction, then there's no from. And message.sender basically tells you where it's coming from. So that's why message.sender, that I was saying, doesn't work in view functions. But in this one, it works fine, because this one we're modifying the state. It's not a view function. So it generates, so calling this function will generate a transaction, meaning that we will actually have a message.sender. Does that make sense?
Yeah, that makes much more sense. Yeah.
Okay. So now we have our storage, our storage array contacts. All right, so what we want to do is, so how do you append something to a storage array? What do? You push, exactly, you push. So we can just do contacts, dot push, contact. That's it. All right. And the reason why now some of you might say that, okay, well, you took the values from storage, put it into a variable, and you pushed it to the variable. But wouldn't that not modify the storage? Well, so what happens here is if you declare this variable as a storage type, as a storage array, it means this variable does not hold any concrete values. It doesn't hold an array. What it holds is a pointer that points to the location in storage where the array is located. So when you're doing push on this storage variable, what you're really doing is you're pushing on the thing that is pointing to, which is directly in storage. Now, if you change this to a memory, it's a different story, because, and again, you can't push to a memory array, first of all. But secondly, even if you could, so instead of arrays, let's say, so structs work in the same way. So if you have a mapping that maps from something to a struct, if you pull out the struct as a storage variable, then that struct variable is actually pointing to where that struct is located inside of storage. It doesn't hold, so the variable itself doesn't hold the actual values of the struct. But if you pull that struct out as a memory variable, then that variable won't point to any location in storage. It will just hold all the values. It will basically copy the storage into memory and then hold it there. So whatever changes you make to the memory variable will not be reflected in storage.
So that makes a lot of sense. But then why couldn't you just push it directly as opposed to creating this new?
You could. I just did this to make it more clear, but exactly, that's what I'm going to say. You can do this directly.
Okay, cool. Yeah, but no, thanks. That explanation actually helped.
Yeah.
The previous example, if I called from a different contract, would that change because you're the same storage function is, or the same array is called the same thing, it's just called contract, but that just wipe what previously was there, and, or it just depends.
Which one, sorry?
I guess I'm saying if I called from one contract and then repeated it with a different contract, the message.sender would change. With the storage, the contacts array, how would that influence it? Would it change it?
So
Because I can't have two
for
contacts.
each address, it's a separate array
Oh,
that
okay.
they're pointing to. Yeah, so they're independent, they don't affect each other.
Could you just show us it this way to kind of give us an idea of the logic, because it seems like the other way is.
Yeah. This way, I'm just trying to, I guess, because this one's a one-liner, it's very easy, but I guess, I don't know, maybe some people prefer the other way, so that's what I did. But I would do this. And this is actually maybe more clear because you're directly interacting with the mapping and whatever, as opposed to like you're placing it into some variable and then interacting with the variable. But in the future, when you get to gas optimizations, there are different there are different ways to optimize gas. Sometimes doing this might be more expensive, sometimes doing it the other way is more expensive.
Really?
And we'll talk about it, we'll talk about why. But for now, we don't have to worry about gas. All right, so does this function make sense, everyone, 125?
Can I ask a quick question?
Yeah,
Could you explain like the storage arrays? Do those always allowed to be pushed? Like, are they always dynamic if it's in storage?
yes, well, storage arrays are dynamic. Storage arrays can either be fixed or dynamic. Because you see, because I can specify a size here, and this is fine. But if I do this, it means every single array that an address points to can only have 4 elements max. But because I didn't specify, so it will be a dynamic storage array instead of a fixed size storage array.
Okay, so storage doesn't guarantee it'll be dynamic, but because you didn't specify the size of the array in the mapping, that makes it dynamic, which allows you to push.
Yes.
Cool, thank you.
Any other questions regarding add contact? No more. All right, so let's move on to set contacts. All right, so what this one does is it just, instead of adding to an existing array, you're just replacing the whole thing. You're overriding it. Now, I saw some people, what they're doing is they're basically taking the storage array, popping out all the elements, and then adding in all the new elements in this contact in the input array. You don't have to do that actually. You can directly overwrite what's already there. So what we can do is you can just do contacts message.sender. Just make it equal to contacts to the input contacts array. That will directly override everything that's already there. Right. So it will basically clear out what's there and then assign a new value to it. And you don't have to manually do the pop and push. That's actually a lot more expensive. All right.
This is more a question related to when I was testing it. So I was able to put in an address out or without quotes for the other functions, but when it came to that one on Remix, I needed to put quotes around the address, like within the brackets. I'm just wondering do you always have, like, because I didn't have to do it for the other ones, but it was just a single address. It was already, so I was just curious why that's.
Do you have to do it, or does Remix do it for you after you submit the transaction?
Oh, well, it might,
Because
I think
Remix,
it might have.
what
Yeah.
Remix does is, I don't think you have to do it, but Remix adds quotes to your input
Okay.
after you click on the call button.
But like if we weren't using Remix and it was like just VS Code or actually deploying.
So that's a good question. I briefly covered it on Piazza. We can look at post. I don't think, probably not supposed to show private post. Let me find it and then. Oh, there we go. It's a public question. Yeah. That's cool. Okay, so this is my answer. Okay, so the reason why remix adds quotes, this is terrible. The reason why remix adds quotes to, you'll notice, adds quotes to your numbers, especially, right? Which doesn't make a lot of sense because once you have quotes, they become strings. What's happening there? So this is because UN 256 covers a huge range of numbers. And the range actually exceeds the default number class in JavaScript can represent. So it actually goes over the range of whatever JavaScript can represent natively. Okay, so by passing it in as strings, it won't cause an error on the JavaScript side. So on your front end side, it won't cause a problem. And it will know, so what the framework or EVM will do is, well, first try to decode, it will try to convert your string into the appropriate type, see if it's actually that type within it. If it's not, like if you're passing letters for a number, then we'll throw an error, obviously. But if the decode does come out to be a number, then it will just, because so in their system, they use something called big number. And by default, JavaScript just uses number, and big number has a much bigger range than number. You can probably tell from the name. Okay, it's a big number. Okay, and in the future, when we get to the front end part, you will notice that whenever you make a call to a view function, whatever, any function that returns some values, a numerical value, you will notice that they're not plain numbers. They're big number. They're of type big number, because it's very easy to go over the limits, and they don't want to cause an error in JavaScript, so they use a custom class. But for you, it's much easier for the user to just pass it in as a string instead of constructing a big number. You can still construct a big number from a string, by the way, and perform operations on it. But that's kind of why it's passed in as a string instead of like a plain number or plain address. Because what's an address? At its heart, it's hexadecimal, and what does that represent? It's a number. And it might go over, I'm pretty sure it does go over JavaScript's ceiling or whatever. The maximum number that JavaScript can represent, natively represent. So that's fine. Okay. Does that, yeah. Okay. Any questions on these three before we get to the actual credit part? No more questions on this. All right, let's get to the extra credit. So what does the extra credit say? It's 2%. It's a lot of money or points, right? So this is fairly, I have to stop saying this. I was about to say it's fairly simple this time. But it's fairly straightforward. We're just trying to associate contacts with names, right, for a specific person. Now we have to really think about this, because let's say Jin and we both have Chase as a contact, but we can very well give him different nicknames, right? So for Jin, it might be Chase. For me, it might be Student Chase, whatever, right? But the point is, you have to make it so that even if it's the same address, but when it's in the contact list of different people, the nickname could be different. You have to accommodate this case. Okay. So again, before we start writing any code, we have to think about the logical, relationships or steps to solving this problem. So basically, what's the relationship here? I'm saying some person has a list of contacts, a list of addresses. So some address points to a list of addresses. And for each address within the list of addresses, they can point to another string as a nickname. right? So we have an address pointing to, so we have many addresses pointing to many addresses. So we have many addresses, and for each address, points to, again, many addresses, because for each person, you can have a list of contacts, right? And for each address within that contact, it points to a single string. So we have a many pointing to many pointing to one. That again sounds like a mapping to me. Okay. It sounds like a mapping that points to an address to what? Now, not to an address array again, because we have to make it so that every single element within the array can have their own nicknames. Otherwise, you're just giving your contact list a nickname, which doesn't make sense. It's just a contact list, right? What do you want to name it? So it should be a mapping of an address. So again, whenever we say multiple things pointing to something, that is a hint of you using a mapping. And whatever thing that's like whatever the multiple thing is, that's usually the key of a mapping. Okay, so in this case, we have multiple addresses, each of them pointing to multiple addresses, each of them pointing to a single string. Okay, so that's mapping as a key to the map, a key to the mapping pointing to another key to the mapping pointing to a value. Okay, so in this case, it will be a mapping that points from an address, right? So this is the owner of the contact list, okay? Pointing to another mapping of an address to a string. Okay, I'll just name it nicknames. So this represents the owner of the contact list. This represents all the possible addresses within the list of contacts. Because again, you don't know who's in the array, so you have to make it so that all the values are probable or possible. So it's another mapping. And then for each address in the contact list, it's associated with a single nickname. So that's why it's a single string. Okay. Is everyone clear on this part? Or is anyone not clear on this part? We can. Yeah.
Would a struct come in later, or could you do this?
That's another approach. We'll talk about.
Okay.
That's a different approach. Yes, but it's equally valid. Any questions on this part? I'll go for the struct approach later. It's another approach. Any questions on line 33? How we came to this, came up with this mapping? Okay. No questions.
Oh,
Yes.
how come it couldn't be a mapping of an address to an array of addresses to a string, because it's a list of.
It's, but the problem is once you do that, okay, so you're saying swap this out.
Yeah, like hypothetically, if that was an array, what would happen?
So this?
Yeah.
So you're saying that, so first, I don't think an array can be a key. But on the other hand, what you're saying is this person has multiple contact lists. And for each list, you give a nickname to that list.
Oh, so you're doing it for each individual contact, that makes sense.
Yeah. No more questions. All right, let's move on a little bit to the actual functions. Let's copy and paste it. So we have get nickname and set nickname. Let's start with this one. How to get it? Well, we have the caller, who's the owner of the contact list. And then we have the specific contact within the list that we want the name of. And then we want to return a string, which is the name. So this is fairly straightforward. Just return nicknames, caller, contact. Does this make sense? Or does this not make sense to anyone? All right, so let's move on to set nickname. All right. And what we do here is we just, we also, because the hard part is getting the mapping down. Okay? Once we have the mapping, then it's fairly easy to do things. So all we have to do is we do nicknames here. And again, because it's not a view function anymore, so we know who's calling it, right? So we used to call this address, which is message.sender, and then contact, and we basically assign that specific contact within the list of contacts of this message.sender a specific nickname that we also pass. Does this make sense there? Does this not make sense to anyone? Okay. So now I shall demonstrate the second approach, which is using structs. Okay. But by using structs, we're kind of solving both question 3, both this part and this part as a whole, more or less. All right, so let me start off a new contract because let's just call it homework 3 extra credit struct. Okay. So we have to think about it. So what's going on here, right? So first we have a list of contacts, right? So what can each person have? They can have a list of contacts, and then for each person within the list of contacts, they can have a nickname. So each person can have 2 things: a list of contacts, and then some registry that holds the nickname for whatever person that exists within the contact list. All right, so we can represent the caller storage as like a struct. So we can call this struct. We can call this contact, or how do they call it? Just call it contact. Okay, let's name it contact. And within here, and you see the how can we? One way we can kind of we can kind of know what to put inside of the struct is. Take a look at these 2 mappings, line 18 and line 33. Okay, they both map from an address to something. Okay, so because these 2 addresses are referring to the same thing, whatever this points to can be put inside of a struct. Okay, so we can just copy this over. So the struct contact can hold an address array. Call it contact list. Okay, and then it can also hold a mapping. And then we'll have a mapping that points to an address from an address to a single struct. Does this part make sense? How this approach kind of packs the previous approach? So it's packing the contents of 2 mappings into a single struct, and then creating another mapping that points from the original address to the new struct. This may not seem like much when you only have when it only has 2 members, right? But imagine when you have 5, 6 inside a struct. If you don't use a struct, you're going to have 5 or 6 mappings. But if you do use a struct, you're only ever going to have 1 mapping outside of it. Okay. And what we do here is fairly easy.
Can you explain that one more time?
Yeah, which one?
Yeah, why would you need 5 or 6 mappings out of struct versus with 1? Don't use them.
Because let's say, let's go back to this example here. With the student thing, right? let's say you want to keep track of each of these. You want to keep track of 4 things. Right? Well, the only way to do it is to use 4 mappings, right?
Oh, I see what you're saying.
Yeah. But with a struct, you only need 1 mapping ever. That just points to a struct, and that struct pass everything into one structure, which is a struct. Does that okay. And the way to, for this approach, let's copy this. So get contact will just be contacts color dot contact list. Okay. So now you're returning a specific variable that's declared within the struct. All right. So calling this will give you the entire contact struct, and dot contact list will give you this specific variable within the struct. Okay, for this one, it's more or less the same. We'll just have to do dot contact list dot push. All right, and this one's dot contact list equals contact. Right, because the mappings sound different, so we're pushing to and replacing slightly different things now. But do you see how this gives us a struct back? And then within the struct, we're trying to modify or replace this specific variable. Is that clear to everyone what we're doing? All right. So I have to wrap this up in a bit. I have homework thing. I guess I'm not doing code reviews today. So for the nickname thing, right? We no longer have a separate mapping for it. Okay. So we have to do is still contacts and caller. When we get to this point, what we get is the struct. Okay. But then we want a specific nickname that an address points to inside this mapping, right? So we do nicknames at contact. Okay, so that's get nickname. And set nickname is more or less the same. Just copy and paste it. And we have to change this to message send. Does this part, anyone have any questions on how the struct version works? No more questions. This is fine. I realize it might take a while to digest. And feel free to ask questions regarding this on Piazza. But for now, we kind of have to move on a little bit because we spend a lot of time on this, right? So let's move on to what we're going to talk about today, which is conditionals and events. Which, we're probably only going to get to conditionals. Okay. Conditionals events. We already did code review. So conditionals, this is why I took out get max, because in get max you have to make a decision. So you have to make use of a conditional. So conditionals basically tell the program how to make a decision. Right? Something like what to do if something. Right? What to do if something. What to do if the input is smaller than 5. Else what? What to do if the incoming amount of ether is less than 1 ETH. Right. So the general pattern of a conditional in Solidity and in many other programming languages is if some condition is satisfied, then you have a code block that does something. But else, if some other condition is true, then do something. And you can have as many else ifs as possible, but their criteria shouldn't overlap, right? And at the very end, if none of the above is satisfied, then do something final. So with the conditional, you always cover all bases. All right. So yeah, we'll get to example in a bit. Or okay, we can talk about this one first. Okay, for an extremely useful function called is your number big enough? Okay, so it takes in a number and then returns the message. Okay, so what's happening here is basically it's saying, I'm just going to read this in plain English. Okay, so if the incoming number is smaller than 5, then return your number is under 5. If your number is greater than or equal to, so this means greater than or equal to 5. This just means and, right? And in English. And we'll talk about this in a bit. So if your number is greater to or equal than 5 and smaller to or equal than 7, then return this message. And if neither of these is satisfied, then return this, right? So what does neither of these satisfy mean? We've covered all the numbers smaller than 5. We've covered the numbers between 5 and 7. What does this cover?
Any number above.
Yes, exactly. So else always covers all the cases that everything above it don't cover. Okay, so that's how conditional works, kind of, and we'll come back to this in a bit. But in order to really to show you guys how that works, we have to talk about something else. We'll have to talk about logical operators. Now, we briefly talked about it last Wednesday. Okay. So what are logical operators, right? It's a symbol of word that's used to compound multiple Boolean expressions. All right. Basically saying that if you have a series of true or falses, and then using different logical operators, you're able to combine them in different ways and basically combine multiple Boolean values into a single Boolean value. Okay. It's actually used across all of the engineering disciplines. It's actually also used in your daily lives, and I'll show you how in a bit. So there are 4 common logical operators, and actually the last one is actually not so common, but these 3 are the most common ones: and, or, and not. And these are symbols representing. So in code, 2 ands is an and, 2 vertical slashes is an or, an exclamation mark before something is a not, and then this is an XOR. Exclusive or, and which we'll talk about what that is. Okay. So let's talk about this in plain English first, okay? So in real life, this is something that people would say, I guess. I want to graduate and be successful. Okay. So what do you really want in this case? Do you want to not graduate and not be successful? That's not what this sentence means. Do you guys agree? Do you want to graduate and not be successful? Is that what the sentence means? No. Do you want to not graduate and be successful? Some people want that, but is that what the sentence means? What the sentence really means is you want to both graduate and be successful. Right? Does everyone agree on this English lesson? English is my second one. But so in code form, right? The logical and basically means given 2 conditions, both have to be true in order for the outcome to be true, right? So just like this, I wanted something and something. Both need to be true in order for the sentence to be true. Okay. So if A and B, right? If A is false and B is false, then the entire thing is false. If only one of them is false, it's still false. It's only true when both of them are true. And this corresponds to this slide, right? See, not graduate, not successful, 2 falses is false. So, and if either one of them is false, the entire thing is still false. It's only true when both of them are true. Okay, this is something that you just have to remember. Okay, like this is just how it is. Now let's move on to or. I can say I might go do some work or grab food. All right, so what do you want to do? Do you want to not work and not grab food? That's not what you want to do, right? You want to work and not grab food? Yeah, because I said or, right? It could be either one. But if I wanted to do both, that's totally fine too, right? So for an or, only one of the 2 conditions needs to be true in order for the entire thing to be true. Okay. When both are false, the or is false. But even if only one of them is true, the whole thing is true. And when both of them are true, the whole thing is true. Any questions on or? This is like a CS English lesson. No questions on or. Okay. Not. You know, when you're in elementary school or USC, you wake up, I don't want to go to class. So I don't know, maybe. But what do you want in this case? Should be fairly obvious. Do you want to go to class when you say I don't want to go to class? Hopefully everyone knows what this sentence means, right? Do I mean not to go to class when I say I don't want to go to class? Right. So a not basically negates whatever comes after it. All right. So if the statement after, so if the state so this is not A, right? When A is false, not A is the opposite, which is true. When A is true, not A is the opposite, which is false. Okay, so not just flips the Boolean expression. And you can only use it with one Boolean. So unlike the other two you see, it's a combination, right? Not is it only applies to one. Okay. Now this is called exclusive or. Okay. Exclusive or means only one of the 2 statements can be true. If they're both false, it's false. If they're both true, it's false. So this is the main difference between exclusive or and or. So only one of them can be true, not both of them, not neither, right? You must either work or get fired. Okay, what happens? Do you not work and not get fired? No, because it says you have to either work or get fired. Do you work and not get fired? Yeah, right? You work and you don't get fired. You don't work and you get fired, right? That's still true. You work and you get fired? That's terrible, right? That's false. So this is how exclusive or works, right? So only one of the 2 can be true. When both are false, it's false. When both are true, it's false. We almost never use this, but this is still like, I just wanted to mention, okay? And also, a lot of people, when you're doing exponents, right, like 10 to the 18th, you'll be tempted to use this, right? But do not use it because that's what it means in code. To raise 10 to the 18th power, you just type in 2 asterisks, 2 stars. Like 10 star 18, that means 10 to the 18th. Right. So let's check it out. Check out the conditional thing in code a bit more, right? Okay. So we so let's go back to the first one first. When I want to check if a number is larger or equal to 5 and smaller or equal to 7, it means it has to satisfy both conditions, right? It has to simultaneously be larger or equal to 5 and smaller or equal to 7. So I need both of them to be true for this to be true, for this block to execute, right? So I use an and because I need both conditions to be true. Does this make sense? Does this not make sense? Any questions on this part? No questions. Okay, so let's move on to this one. One-time deposit. So what's happening here is, I'm basically, so for this function, for this contract, I'm making it so that I have a whitelist of people, all right? And for each person in the whitelist, you're able to deposit 5 ETH and exactly 5 ETH. All right, and you can only deposit once. So these are the rules. You have to be in the whitelist. If you're in the whitelist, you cannot repeat deposits. And so you can only deposit once. And when you deposit, it has to be equal to 5 ETH, the value that you send. Okay. So down here, we just have a function that whitelist the column, which is pointless, but I didn't want to come up with any clever rules at 3 AM. Okay. So if you call this, you'll just whitelist yourself. So the whitelist is pointless, but I wanted to have another one to demonstrate something. Okay. This function, deposit external payable, what does that mean? So this is, so we have nothing, we have pure, we have view. These are the 3 that we already know, right? And we also have payable. What payable means is that this function not only modifies the state. Sorry, this function, it means this function accepts the payment when you call it. It's payable. So if you call a function that's not payable and pay it money and send funds with it, it's actually, I think it's going to revert or go to like, go to a fallback function, I'm not sure, but if you call a function that's not payable with funds, it's not going to work. Okay. And does anyone want to guess why payable is in the same category as view and pure? Meaning, why can't you have payable view?
It's the transaction that writes to the blockchain and it's
What does it write?
or updates the balances of
Yes, so
users or
the account state,
yeah.
right? For the smart, even for the smart contract account, it has a state. The state has 4 different components. One of them is balance, right? So when you're sending the contract money, when you're sending it to a payable function, you're modifying a state. It's just not like the contract storage state, but it's the contract accounts balance state. You're increasing it by however much you're sending, right? And this is why payable cannot be used with view or pure. And why it's like in the same category, so you just can't use it at all. Yeah.
How does the function know what the value is?
Message.value.
But whenever you're interacting with it, I understand how it knows message.sender. But where does it see the value? Like, what is the message.value connected to?
So let's deploy this. If you're whoops, that's the wrong. So we have deposit. And remix actually doesn't have the option. But you see here how when you're deploying a contract, you're able to send value with it. So you're actually able to send value with your call to the contract, and that's where the message.value comes from.
So by default, it just includes the value.
If a function is not payable, and if it is payable and you don't send anything, message.value is just zero.
Okay.
Yeah. So I'm checking for a few things. Remember the rules. You gotta be whitelisted. You can only deposit once, and when you deposit, it has to be 5 ETH exactly. Okay. So what am I doing here? I'm using revert functions. So revert just means rolling back a transaction. I'm now using require because I want to demonstrate the ifs. Okay. So the first thing I'm checking that the message value, if the message.value isn't 5 ETH, or the user has already deposited. So notice how it's an address to a Boolean. So by default, they're all false, right? If someone deposits, I set it to true. Okay. So if this is true, if this returns true, I know that person has already deposited. So the rule is you can only deposit once, right? So either one of these two, if either one of these two happens, then I got to revert, right? So if the value that's sent with the call is not 5e, or the person has already deposited, then we revert, we revert. That makes sense in English. Kind of makes logical sense, right? If we pass the first test, we say, okay, that doesn't fit our criteria. Then here comes the next condition. Else if this person is not in the whitelist. See, so this is not equals, all right, and this is not in the whitelist. Because if the person is in the whitelist, then this will return true, right? But the negation of true is false. Right? So how the way conditional works is that the conditionals will only go into a conditional code block if everything in here, if this entire thing is true. Okay, it's one thing is true. And the else if will only go into this revert if this is true. Okay. Now, if the person's already been whitelisted, then this will be true. The negation of true is false. So which means if the person has already been whitelisted, then this will return false. So it will not trigger this. On the other hand, if the person has not been whitelisted, this will return false. False negated is true. And if this is true, then we'll go into this else if code block. And we'll say that the person's not whitelisted.
So can you not just do like whitelist message.sender is equal to false?
Equal equals to false. It's two equals.
Sorry, yeah, equals
Yeah,
equals
you
false.
could.
Okay,
That's another way of doing it.
okay, but if you don't assign, I guess like another Boolean variable on the other side of the equation, then it just takes it and says like, if this is true.
Yeah, yeah.
Okay.
Because the equals thing, fundamentally, that in itself is a Boolean expression that returns a single Boolean value, if it's equal to it or not.
Okay.
Right, so that still gives you a true or
True.
false.
Oh, okay, yeah, makes sense.
Yeah. So if that person, so else means none of the criteria fit, meaning if the person did send 5e and the person has not deposited and the person is whitelisted, then we take the money and then we set the deposit record of that person to true. Okay. So the negation of an or is an and. Right, so you can see here. So basically else is saying that, so let me go back again. Else basically means none of the above is true. Right, and that basically means negating all of these terms. Right, by negating this one, I'm saying that, so let's negate it one by one. What's the negation of this? Not equals. Equals, right? That's the opposite of it. So first we're checking. So else means that this person's message.value is equal to 5e. The negation of or is and. So instead of one or the two, it's got to be both. So the person's did send 5e. And the person, what's the negation of this? Just add an exclamation mark, right? And that means, so this has to return false for the negation to be true.
Yeah, okay. That makes sense.
Right? So we're saying that this person has to have sent 5e and the person has to have not deposited.
Cool. Yeah, okay.
Right? And then, and also the person has to be whitelisted because the negation of a negation, you just get rid of the exclamation mark. So this also has to be true. Then we will execute here. Okay. Does all that make sense there, or not make sense there? I can go through that again.
I just thought like in English, if you said if message value, so you're saying message value has to be 5e, why wouldn't you say if message value equals 5?
Sorry, what?
Like if in this case, if it has to be 5e, why wouldn't you just say if message value equals 5?
1 equal or 2 equal?
2 equals.
But I'm checking here because if it's 2 equals, then if I send 5, which I want to send 5, you'll go into this revert. Because one of 2 ORs is true. One of the 2 things in an OR is true. This will be true, so it will go into this. Right? So we're checking all the negative conditions first. All right, and then and then at the very end, we're kind of saying, okay, all of the criteria are met, and then we kind of finally go into this part. So the else implicitly negates all the other ones, right? So basically, this else I can expand it into else if, okay. And let me just so it's basically else if this is equal to this, and this is not true. But we also have a second condition here, so we also and it, and that person is whitelisted. So this entire thing is the same thing if I just get rid of all that and just say else. But you see how it negates everything that we checked up here. To check if if these two check 2 kind of areas, conditions, whatever, then this one makes sure that all the other conditions are covered in this case. So basically the opposite of everything. Think of it as this one covers a small circle of cases. This one covers another small circle of cases. Then the else must cover all the other ones. So you're just inverting whatever you're checking here. It's like in Photoshop when you select something, and then when you invert, you select everything else. So this entire thing, it's the same as a single else.
I might have missed this, but why is that saying it's 5 to the 10 to the 18?
Because this is actually in waves. So 10 to the 18th way is 1e, but I want to make sure they're sending in 5e. So it's 10 to the 18th.
So is that what you always have to do?
Yeah. And you make sure you don't forget to do it. Otherwise, you're undercharging by a huge margin. Anyone have any questions on the ifs, else ifs? And by the way, you can have as many else ifs as you want, but there's got to be one initial if. It's got to be one last else. You can have as many else ifs in the middle as you want.
Is there any other way to do like 10 to the power of 18, or is that just the double multiplications?
So
Do you always have to end with else, or can you end with an else?
well, let's see. Right, you could, but then you're not covering all the scenarios. The only times when it's acceptable to only have an if and nothing else is if you want to deal with a very specific case. Right, actually I take that back. So you always need an if, but you can make it so that you don't have an else, or you can make it so that you don't have else ifs. But there's gotta be an if to begin with. But if you want to cover all bases, then you need an else. Because an else is like a catch-all that catches all the scenarios where it doesn't fit the ones above it. So if this is not satisfied, then it has to drop in else. Okay. Yeah, so you can, it is okay to only have an if. I actually, yeah, I made a mistake. So, and it is actually okay to only have an if and else if. But then, you're not doing anything in else. But in this specific case, it's actually okay to not have an else. Does anyone know why?
It's essentially nice. If neither of those runs, that's.
Yes, yes. And also, there's another point. Because we revert directly. So if you're still here, like if the execution gets to this point, then we're sure that it does these two checks have failed. If I do not revert, if I don't revert, then we cannot do this because let's say the person didn't send 5e, it will go into this if, but then it will come out of it and then proceed to this, which is not what we want. But because here we reverted, so we just cancel the transaction, so it's not going to proceed anymore. So it's okay to not have an else. But usually, just to be safe, always have an else. Okay. Like if you're just starting off, just to be safe, always have an else. Once you kind of get the hang of, you kind of know what you're doing, you can start to omit the else. Any questions? Any other questions?
So revert just says, bring me to the end of this conditional function.
The revert just says, stop immediately and then roll back. Cancel the transaction, return with an error message. So this if thing, I can easily rewrite this into a require. Because what does require do? It checks conditions. If the conditions are not met, then it reverts with the message. What are we doing here? We're checking for conditions, and if the rules are broken, then we revert. So I'm not using required on purpose to show the ifs and elses.
Sounds good.
So if I were to rewrite this with required, then it would be it would actually be the so I need both of these to satisfy. So it would be the negation of this. So it will be message.value equals and that person has not deposited. Otherwise, I'll give an error message saying this. All right. Yeah. All right. So this is the same as the first if that we're doing. And also, when you guys are doing this, make sure for clarity, always add parentheses around things, right? To explicitly show the priority of operations, just like in math. Okay. It's easy to overlook things, but it's good to be explicit when you're starting off, right? So the rule is the equality and inequality stuff will always be compared first. And the not thing will always be compared first. And then we do like ors and ands, but between ors and will have priority to be evaluated first, and then we go to or. So you see, like there's a lot of rules regarding that. So just to be safe, to show your own intentions and not make mistakes, just add parentheses around things. It's not going to hurt. So in this case, you can just explicitly do this, right? Just to make it very clear what we're trying to do. And this is totally fine.
So the require seems a lot easier in this case. So what are some instances where you would have to use the if and else if versus just using require?
Like if you don't want to revert, but you want to do something else. Because require just reverts immediately. Like let's say if you want to, if you don't want to revert, let's say in this case, you want to return a different number instead of reverting or whatever, use if and else. Yeah. Let's say you have let's talk about investments, right? A vesting schedule, right? So the gradual release of funds, let's say it's a linear vesting schedule. You can use the ifs and else to check the current time. You use block.timestamp to check the current time. And based on the time, because it's a linear unlock, we can decide how much is available. Right, so that's the case where you need a bunch of ifs and else. Or let's say, depending on the value of ether you send in, although this is very poor practice. Let's say you're able to buy different assets, buy different game assets using a single function, and you differentiate by the amount of ether they send in, although this is very poor practice because you have different functions that sell different things. Or you shouldn't use the amount of money sent as the indication of what people are choosing. But that's like another case. You can use ifs and else ifs, a bunch of else ifs, depending on how many things happen in an else. Yeah, let's say you only accept, so let's say you're only listing 3 items. There are 5, 10, and 15 each. And if they send any other amount, it means they made a mistake. So you can have if the message on value is equal to 5, else if is 10, else if is 15. And then the last else will be all the other amounts, and you just say that you made an error, reverse. Yeah, and also if once we go into a certain conditional block, we no longer proceed to the other ones, we just leave directly. Right. So if you want it, so this is also why sometimes you use an if and else if, but other times you might want to use 2 ifs. Because if you do if A, else if B, if A is true, then B will never be checked. But if you do if A and if B, then even if A is true, it'll come out of the A conditional and then go into and then check else if B. If that makes sense.
Wouldn't you just in that case do A and B in the same or function in the first if?
So when you have 2 ifs, you're saying,
Why not just do one if and then have an or function?
let's say depending on which one is true specifically, you want it to do different things, and or just tells you if one of them is true.
Okay.
Yeah.
Yeah, that makes sense.
Yeah. Are we good with conditionals? Basically, telling the computer what are the how to make a decision. And we can stop here today. Homework 4. Still thinking about it, what to do. It's going to be due on Wednesday full class, so we have a lot more time. What I'm thinking is I might get you guys to make like a money splitter. You deposit the funds into a contract, you split it evenly among like a certain number of people. Yeah, that's it for today. Thanks for coming, guys.
Thank you.
Yeah.
Thanks for that.
And don't forget to post any questions on Piazza. If you email me, I'll email you back later. Okay.
Wait, so the homework is due on Wednesday?
Homework 4 will be due next Wednesday.
Oh, okay, cool.
Because Monday we don't have class.
Okay. Hey, Jack, can you stay on Zoom just for like 2 minutes?
Contract where we had collaborate on them. Is it possible to write a contract that splits royalties specifically for a sale on a specific item? That will take from like a central wall where all the royalties go to, and then properly, but not, it wouldn't be like too much data on the contract. No. I mean, you do fully on.
I have a quick question, stuff for the extra.
You kind of have to do it, but otherwise what's trust?
Was he a day?
Yeah, because like when we first read the contract, we had no idea how to do that, so we told all the
And then I
collaborators.
thought you were gonna do it for you, 20 for you.